Hi pre-calculus students, this is Mr. Chun, and we're going to be talking about solving trig equations today. This is on section 7.7 and 7.8. Okay, let's start with 7.7. How to solve trig equations that have a single trig function in them. Okay, so this is our objective. A couple things before we start working some problems. Unless you're told otherwise, please restrict your domain to 0 and 2 pi. Okay, so the domain on your angle should, in general, be 0 to 2 pi. So that's one full revolution of theta. Never divide by your trig function. Okay, what that means is if I end up having like a, I don't know, let's try cosine of theta equals 1/2. If I have that, never divide both sides by cosine of theta to try and simplify. Whoops. Okay, never do this. Okay, that's bad. What ends up happening is you end up canceling out some possible answers, some possible solutions, so we don't want to do that. Okay, so never divide by a trig function. Get all terms of an equation in terms of one trig function if possible. So if I have multiple trig functions present in an equation, try and get it all in terms of like sine, or all in terms of cosine or tangent, or just try and get it in terms of one trig function. Sometimes that will not be possible, and we'll look at a couple examples on that. Okay, so let's get started. The first example is finding the solutions of a trig equation. Okay, here it says solve cosine of theta equals 1/2. Because it doesn't say explicitly to find all possible solutions, we're going to assume that it's going to be between 0 and 2 pi. Okay, so this is going to be our domain, restriction on our domain. If we want to find the angles, the values of theta when cosine is 1/2, we can look at our unit circle. And we know that because the cosine is going to be positive here, we know that it's going to be on this half of the circle because of ASTC. All right, so we're going to look at the angles here. All right, this is it's going to be pretty obvious that this is the theta is here going to be 60 degrees, or in radians that'll be pi over 3. Okay, you should know that from your unit circle. From the table. We've been practicing that for a while now. So theta is equal to pi over 3. But we also know that there's another angle when the cosine of theta is 1/2, and that's at negative pi thirds. But our answer, we want to find it, our theta in positive numbers from 0 to 2 pi. So we have to go the other direction. So we're going to come back to this point, but instead of going down, we're going to go around this way. Okay, so what is that angle? Well, that's going to be really just 2 pi minus pi thirds, and that will be actually 5 pi thirds. Okay, so within this domain, we can say that our angle, the possible solutions to this equation here, are pi thirds and 5 pi thirds. Okay, so that's going to be our solution set. I think your book says write it like this, which is fine. Okay, so this is under the condition that theta must be between 0 and 2 pi. Okay, and you can check this on your calculator too. If you graph, for instance, if you graph this on your calculator, make sure that it's in radians, and then graph this on your calculator on the same window, you're going to see something that looks like this. Okay, so the cosine value, the cosine will keep repeating. We're only interested again in from 0 to 2 pi. So we're looking at this window right here from 0 to 2 pi. And you'll see that the line y equals 1/2 will be this line here. And so you can see that there's going to be 2 points of intersection where the cosine of theta is 1/2. And that will be at pi thirds and 5 pi thirds. Okay? All right, let's look at another equation. This one is a little bit trickier. It says solve the sine of 2 theta equal to 1/2. So solve for theta and make sure that the restriction is again between 0 and 2 pi. Okay. Now there's several ways to do this, but the way the book tells you one way where you list all of them, but I like to use the unit circle approach. I think it's a little more intuitive. For me it is. You don't have to follow it, but I'll show you my method. Okay, so the first thing we're going to do is we're going to start with by looking at this 2 theta. Okay, we don't like that 2 theta being in there because it makes it a little more confusing. So let's simplify the problem and let's replace this with another variable called alpha, and let's try and change the domain. Let's change the restriction on the domain. So let's try to write an equivalent statement using a different variable. So we're going to use substitution, make this a little easier, and then convert back to theta. Okay, so alpha, let's say let alpha equal to 2 theta. That will make my equation a lot easier. Solve alpha equals to 1/2, and now we have to change our restriction on our domain. So in order to make this 2 theta, we're going to have to multiply everything by 2, and so it becomes now between 0 and 4 pi. Okay? So if I replace this with alpha now, it becomes alpha must be between 0 and 4 pi. So this is really the same statement as what I have up above. All right? It's the same as this. So it makes it easier. We don't have the double angle anymore, and we just need to work off of more than 2 pi. Okay? Work off of we have to find our values of alpha from 0 to 4 pi. So we're just extending the number of revolutions. So now it's just like the previous problem. We're going to draw our unit circle. Where is the sign positive? Because our value here is positive. Well, it's going to be in quadrant 1 and 2. Okay, and then we're going to try and find our angle. What angle will give me a sine value of 1/2? Well, that's going to be pi over 6. Okay, so that's going to be pi over 6. And this is going to be also pi over 6. That's going to be, that's called the reference angle, if you recall. So alpha is going to be pi over 6. Notice that we're going from 0 to 4 pi, so we start at 0, and we're going to go 4 pi in this direction. So we're going to hit, every time we hit this line and every time we hit this line, we're going to record our answer. So we go up, we hit pi over 6, we keep going this way, and we hit, now this position here, from here to here, okay, to get from this line, and when we go all the way over here, that's going to be pi minus pi over 6, or 5 pi over 6. Okay, and we need to go all the way to 4 pi. Oops, sorry. We need to go all the way to 4 pi. So let's do that. We're going to go, keep going. We're going to go from here. Now we've hit pi over 6. We've hit 5 pi over 6. We're going to keep going. We hit 2 pi. And we have to go all the way to 4 pi. So that means 2 revolutions. We have to come back one more time. So now we're at 2 pi. We just need to add 2 pi to this and 2 pi to that. And what we're going to get is pi over 6 plus 2 pi, so that would be 13 pi over 6. And then we're going to come back and hit 5 pi over 6 again. Okay, we're going to come back, hit 5 pi over 6. 5 pi over 6 plus 2 pi, which is 12 pi over 6, is 17 pi over 6. Okay? So now these are my angles if we're talking about alpha. But we said alpha is 2 theta, so let's go back and we're going to what do I need to do to get this in terms of theta? Okay? Well, to change it, we're going to divide all of these values by 2, and then we get pi over 12, 5 pi over 12, 13 pi over 12, sorry, and 17 pi over 12. Okay, so that's my solution set. Those are the angles of theta between 0 and 2 pi that will make this true. Okay? Okay, example 3. Solve the tangent of theta minus pi halves equals to 1. Okay, this is going to be very similar to the method that we used in example 2. We're going to set alpha. We want to again make this part simpler. So we're going to substitute that expression inside with alpha. Also, before we start, let's just set the domain here. 0, theta is going to be between 0 and 2 pi. Okay, so let alpha equal to theta minus pi over 2. And then let's set our domain. So if we substitute that, let's change our domain here. So we're going to go theta minus pi over 2 is between. And then to get from theta to theta minus pi over 2, we have to change this to become minus pi over 2 and this to 3 pi over 2. Okay, so that's going to be our new domain, and now we have to solve this expression. And that's going to be the same thing. So let's draw our unit circle, and let's find the value of alpha when where the tangent is 1. So we know from our unit circle and from our previous work with trig functions that 45 degrees is the angle where the tangent is 1, and so that will be pi over 4. My reference angle is pi over 4. And tangent is, because it's positive, it's going to be in quadrant 1. And there's another angle in quadrant 3. And notice that that reference angle is also pi over 4. So what are the two angles? If we're starting from negative pi halves, so we're starting from here, the measured value is still going to be from our 0, but we're looking at the range from here all the way back to here. So the angle will be pi over 4. And also we keep going, so every time we hit these two lines, we're going to record our answer. Pi over 4 plus pi over 4, so that's going to be pi plus pi over 4 is 5 pi over 4. Okay, so those are my two angles. These are the two solutions that we're going to see, because once we go past that and come back to 3 pi over 2, there are no more values. So those are my two answers. When alpha is between 3 pi over 2 and minus pi over 2, okay, and then we have to convert this back into theta. So we're going to convert these back by adding. Notice that theta minus pi over 2 is equal to pi over 4 and 5 pi over 4. Okay, so if I convert these two numbers, these two back into theta, theta will be pi over 4 plus pi over 2, so we end up with 3 pi over 4, and then 5 pi over 4 plus pi over 2, so that's 2, so that would be 7 pi over 4. Okay, so that's my solution set. These are my two solutions. I could write that in solution set form, where I have 3 pi over 4 and 7 pi over 4. Okay, either of these will work. All right. Okay, example 4. This is a little bit harder, but it's pretty much the same thing. It's just a little bit more. It's a little bit different because we have a secant, but the method is exactly the same. All right. We're going to set alpha equal to 3 pi over 2. All right, and change our range here. So what do I need to do to theta to make it change theta to 3 theta over 2? We have to multiply everything by 3 theta over, or 3 over 2. So this becomes 0. This becomes 3 pi. So that's our new trig function in terms of alpha. Okay. So alpha is going to be between 3 pi and 0. So We have to somehow simplify this though. We don't like to work in secants, so we're going to change it to cosines, change it into terms of a cosine, so it's going to be 1 over cosine of alpha equals minus 2. And so the cosine of alpha, if I cross multiply and get my cosine alpha on top, it becomes minus 1 over 2. So my unit circle is now going to be looking for an angle. On my unit circle, I'll be looking for an angle where the cosine of that angle is negative 1/2, and so it's got to be negative, so it's going to be in quadrant 2 and quadrant 3. Cosine of 60 degrees is 1/2, or pi thirds, pi over 3. So that's going to be my two angles there. Those are my two triangles. And so let's start. My range is from 0 to 3 pi. So I'm going to start here, and we're going to record every alpha, every angle, when I hit this ray here. Okay, so I always go in this counterclockwise direction, and every time I hit it, I'm going to write it until I get to my the end of my range or my domain. So I start at 0, come over here, and that's going to be, because that's pi, my reference angle is pi thirds, alpha is 2 pi thirds. Okay, I keep going. So I'm going to keep going 2 pi thirds. I'm going to come down to here. That's going to be 2 plus 1 plus 1, so that'll be 4 pi thirds. So we have 4 pi thirds there. Keep going, okay, because we have to go all the way around back to 2 pi. And then we go one more time to pi, right? Because if I go, that's pi, 2 pi, 3 pi, so I have to go all the way to 3 pi. So I hit this one more time. So that'll be 2 pi plus 2 pi over 3, so that'll be 8 pi over 3. Okay? So remember that we're going to start at 0 and go to 3 pi. Okay, so now we're done with our alpha. We want to change it back to in terms of theta. So to get alpha in terms of theta, okay, we have to multiply our alpha, because we have 3 theta over 2. We want to get alpha in terms of theta, so we're going to change theta to 2/3 of alpha. So we have to multiply all these values by 2/3. And so let's write that over here. Okay, theta becomes 4 pi over 9. 4 pi over 3 times 2/3 is 8 pi over 9. And 16 pi over 9. Okay, so these are my values for this problem. These are the values of theta that will make this statement true. All right, example 5. This one, you'll see that this is really 3 over 10. Okay, so this is really the sine of theta equals 3 over 10. That's not really a special triangle, so I know that I'm going to need to use my calculator to find the exact solution. So this one is actually going to require you to use your calculator, but let's go ahead and still figure out which quadrant our answer has to be in using our unit circle. And you can see that it's going to be positive, so we're going to have two answers here. Okay, and the value of our sine is 0.3 radians. So all we really need to do is do this on our calculator. We're going to write theta equals the arc sine of 3 over 10. And if you do this on your calculator, you'll see that the arc sine is about 0.30469 ... Okay, and that keeps going. So if we write this, let's just say to 2 decimal places, we're going to see that theta is 0.30 radians. So that's going to be 0.3. We still need to find that angle because there's two angles that will make that, when I take the sine of them, will give me 3 over 10. And so that angle will be pi minus 0.30, or that. And so my angle is 0.3 radians, or if you do this on your calculator, 2.84 radians. Okay, that's pi minus 0.3. All right, so those are my two answers for this situation. Okay, so these are your practice problems for 7.7. It's very similar to what we've just been doing. And let's move on to 7.8. Okay, so 7.8, more trig equations. We're going to look at trig equations that are quadratic in form. So you have to, you'll be seeing something that looks like a quadratic. Okay, 2x squared plus 3x plus 1, and we'll set it equal to 0. We can solve this by factoring, right? We can solve this by factoring and then setting x equal to whatever. Okay, so that we're going to be solving trig equations that look like this, except instead of x, we'll have different trig functions. We'll be using identities to maybe replace a complicated looking equation or expression with a simpler one, and then we'll talk about how to solve trig equations that are linear in sine and cosine. They have a sine and a cosine in them, and also how to solve trig equations using a graphic utility. All right. Example 1, solve a trig equation that's quadratic in form. Okay, so this looks very similar to what the example that I just gave you, where sine was, instead of sine of theta, was just an x. All right, so that's kind of the strategy that we're using. We're going to set this. This looks very much like 2x squared minus 3x. That looks very much like 2x squared minus 3x plus 1. And if we factored that, that would become 2x minus 1 and minus 1. Okay, and so then we could say x equals 1/2 and x equals 1. It looks very similar to this, and that's really what we're going to do, except instead of x, we're going to use sine of theta. So we could factor this. If we factor this, we'd get 2. Okay, let's go ahead and show you how to do this. I'm gonna write my 1's here. 2 sine theta here, sine theta here. These are both minus because that's got to be minus. This becomes 2 sine theta minus 1 equals 0, and sine of theta minus 1 equals 0. Notice that I have an or here because we have that's equal because that expression is equal to 0. Sine of theta then becomes 1/2, or sine of theta is 1. Okay, so we have two possible solutions or two possible equations that we're going to be working with. So whatever answers I get, this looks very much like what I had earlier, and so whatever answers I get from here and whatever answers I get from here, we're going to combine them and make sure that we check them as well. Okay, so we're going to combine the answers here and then combine the answers here. This is very, very, now we're just doing what we did in 7.7. Okay, so let's draw our unit circle here. Where is sine of theta equal to 1/2? It's going to be in the first two quadrants, and that angle is going to be, the reference angle is pi over 6. Okay, so our theta, if we start from 0 and go up, we're going to hit that. So theta is pi over 6, and we're going all the way to 2 pi. That's going to be 5 pi over 6. And of course, if we come back here, we're going to not hit any more angles. So those are my answers for that equation. For this equation, where is the sine of theta equal to 1? Well, sine of theta is equal to 1 at this line, at pi over 2, right? So if we come over here, sine of 90 degrees is 1. So theta is pi over 2. Okay, and and now I just need to combine them. And so my solution set is pi over 6, and I'll just write these in increasing order. Pi over 2 and 5 pi over 6. And that's my answer. Okay, and you can check this on your calculator by graphing graphing this and seeing where it's equal to 0. Okay, graphing this expression and then seeing where that crosses the x-axis. Okay, another example. This time we're going to be using identities. So let's see, what can I do to make this simpler? I don't like the fact that I have two different trig functions. So let's try and replace one. We could probably use the Pythagorean identity to replace sine squared theta. So let's try that. 3 cosine theta plus 3 equals 2 times, and the Pythagorean identity tells us that sine squared is 1 minus cosine squared theta. Okay, and now it looks like we might be able to do a quadratic. Let's simplify this. 3 cos theta plus 3 equals 2 minus 2 cos squared theta. Let's get everything to one side because it's quadratic. We get 2 cos squared theta plus 3 cos theta, and plus 3 minus 2. If we subtract 2 to both sides, we get 3 minus 2. Oops, so that's plus 1 equals 0. Okay, and that is now my that looks very much like a quadratic that's factorable, so let's factor that. We get 2 and 2 cos theta and cos theta, 1 and 1. That's going to be plus 3, so it looks like 1 plus 2, so we're going to have plus, and there you go. So my cosine of theta then is minus 1/2, and cosine of theta is negative 1. So we have two situations that we need to look at, and then we're going to combine their solutions. Cosine of theta, where is the cosine of theta equal to 1/2? Let's draw that over here. Negative, it's got to be negative, so it's got to be on this side in quadrants 2 and 3. So my triangle, cosine of 60 degrees is 1/2, so that's pi thirds. So that's going to be pi thirds. My reference angle is pi thirds. Pi thirds here as well. So let's record what that is. So it's going to be 2 pi thirds, 2 pi over 3. So theta is equal to 2 pi over 3 and 4 pi over 3. Okay, and then theta could also be, where is the cosine of theta negative 1? Theta could also, cosine of theta is negative 1 at theta equals pi. So we will write pi here, and so we can write our answers like this. So we would have pi and then 4 pi over 3. So that is my solution set. Okay, those are my possible values of theta that will make this statement true when my angles are between 0 and 2 pi. Okay, so it's this angle, and that angle. All right. Example 3. Solve this trig equation using identities again. Notice that this time we have a double angle. I don't like that, so let's try and replace that with something else. You can see here that this is going to probably, we want to replace this with something that's just cosines. So we're going to try and make this look like a quadratic. Okay. So cosine of 2 theta, well, we learned in the last lesson that cosine of 2 theta is the same as 2 cosine squared theta minus 1. Okay. And let's get everything over to this side. And let's set that side equal to 0. So we can simplify this. We get 2 cosine squared theta minus 5 cosine theta. And we have plus 2 equals 0. So that's my quadratic form. We're going to factor it. Okay, we end up with 2 cos theta, and we have 2, and the sum has to be 5, so we're going to probably go with 2 and 1 here, because that makes 4 and 1. That's positive, so we're going to set that equal to minus minus equals 0. Okay, so we end up with cosine of theta is equal to 1/2 and the cosine of theta, or the cosine of theta is equal to 2. Now, let's see. What is the cosine of theta equal to 1/2? What is the value of theta there? Well, it's going to be here and here. Cosine of theta, that's when this is 60, so that's going to be pi over 3. Pi over 3. And we go all the way back, all the way around. Remember, by the way, remember we assume that the theta is going to be between 0 and 2 pi if there's no specific domain given. So it's going to be pi thirds. We're going to come back all the way over here. So that's really minus pi thirds. So 2 pi minus pi thirds. And that will be 5 pi thirds. Okay. Now, what about this one? What about this other equation that we have? How can we solve this? Well, we can't, because the cosine of theta has to be between -1 and 1. So that is no solution. Okay, so there's no solution here. So that's just an extraneous answer that we get from doing the math. Okay, so this is our answer. Theta equals pi over 3 and 5 pi over 3. All right, example 4. Solve sine of theta cosine of theta equal to -1/2. All right, so let's see, what can we do here? We're going to, again, try to use an identity. Well, sine theta cosine theta, that looks a lot like the sine of 2 theta, except it just needs to be multiplied by 2. So we're going to multiply both sides by 2. We get 2 sine theta cosine theta. And this side is equal to -1. Okay, that becomes sine of 2 theta equal to -1. So notice that we're actually getting to a double angle form. Okay, so you can choose to go to double angle or go away from double angle, but in this case it's probably easier, because now what is this? This looks very much like what we did in 7.7. So we're going to actually set alpha equal to 2 theta and change our domain. Okay, this is when theta is between 0 and 2 pi. So now what does alpha have to be? Because it's 2 theta, it's twice that. We're going to multiply everything by 2. So this is our domain. And so let's draw our unit circle. Sine of alpha is equal to -1 at this angle. Okay, so at 3 pi over 2, when alpha is 3 pi over 2. Okay, but because we are going 2 revolutions, we have to go once. That's once. Okay, so we're going to go from here around. That's 2 pi, and then we're going to have to go around again because our range, our domain is from 0 to 4 pi. So it's 3 pi over 2. We hit that one more time, so it would be plus 2 pi. So it would be 3 plus 4. So that would be 7 pi over 2. That's the second time around when I hit it. Okay? But 7 pi over 2, but we because alpha is 2 theta, we need to divide our alpha by 2 to get back to theta. And so we end up with 3 pi over 4 and 7 pi over 4. And that is now my solution set in terms of theta. And then example 5, this is the last example. How do we solve this type of trig equation when it's linear and we have a sine and a cosine? Okay, well, we can't really replace sine and cosine with anything, so let's try and square it and see what happens. Square both sides and see what happens. So sine theta plus cosine theta equals 1. That side squared equals 1 squared. Okay, and we can do this because if I have a equals to b, then a squared is also the same as b squared. But just make sure that you check your final answer, because when you square something, when you square both sides, you can get extraneous solutions. Okay? So sine of theta plus cosine of theta squared, that simplifies to, well, that's just a, that's a perfect square, so we can rewrite that as sine squared theta plus 2 sine theta cosine theta plus cosine squared theta equals 1. Okay, we have that. That looks very familiar. Those two, if we rearrange those, that would be equal to 1. So we could say 2 sine theta cosine theta plus 1 equals 1. Well, those would cancel, so we end up with 2 sine theta cosine theta is equal to 0. Okay, now if we looked at our previous example, we would have changed this to 2 sine theta, or sine of 2 theta. But because this side is already 0, we're just going to simplify from here and divide both sides by 2. We end up with sine of theta cosine of theta equals 0. And we can actually factor these, or we can solve these separately using the 0 property. Okay, so sine of theta equals 0, or the cosine of theta equals 0. And looking at our unit circle, where is the sine of theta equal to 0? Well, theta is going to be 0 at, or sine of theta is 0 at theta equals 0 and at pi. And the cosine of theta is 0 right here and right here, so that's going to be pi over 2 and 3 pi over 2. So remember I said if we do this, if we square both sides, we need to check our answers because we can sometimes get extraneous solutions. So let's check those answers. For theta equals 0, we have to plug all of these back in. So sine of 0 plus cosine of 0 equals 1. Is this a true statement when theta equals 0? Well, sine of 0 is 0, so that's 0. Cosine of 0 is 1, so yes, that works. What about cosine of, sorry, what about theta of pi over 2? I'm just going to go in order here. Okay. What about theta equals pi over 2? Well, sine of pi over 2 plus cosine of pi over 2, is that equal to 1? Okay, is that equal to 1? Well, what's sine of pi over 2? That's 1. What's the cosine of pi over 2? Well, that's 0. So yes, that works. Let's try pi. Sine of pi plus the cosine of pi, is that equal to 1? Sine of pi is 0. Cosine of pi, what's cosine of pi? Well, if that's over here, that's this angle. Cosine will be a negative 1, so that will not work. So that is an extraneous solution. So we're going to disregard that in our final answer. Let's look at sine of 3 pi over 2 plus the cosine of 3 pi over 2. Is that equal to 1? Sine of 3 pi over 2 is down here, so that's going to be negative 1. Cosine of 3 pi over 2, that will be down there, so that's 0. So again, we have negative 1 equals to 1, and that's not going to work for us. So these are my two answers that do work. The other two are extraneous, so my final answer will be theta equals 0 and pi over 2. Okay? Those are my two answers to this problem. Okay, so this is your assignment, 7.7 and 7.8. For B block, this is due the next class that we meet. For H block, please watch this video, and I'll give you class time to do these problems. All right.